So hi and hello, welcome to our channel named Algo Exploration. My name is Sami and today we will be going to learn how to find the time complexity from the given recurrence relation. Now in the previous video, I have shown you how to find the recurrence relation from the recursive code. So I suggest you to please watch that video. Now we actually have three methods to solve the recurrence relation. Then the first method is substitution method. Second method is recursive tree method. And the third method is the famous master theorem. Now we will study the first method, that is substitution method. Now substitution method says substituting the values repeatedly until the function is removed. So this is the definition of the substitution method. Now let's understand with the help of example. So the recurrence relation is T of n is equals to 1 if n is less than equals to 1 or T of n minus 1 plus n. Now recursive code will spend most of the time in the else part, that is a non-base condition part. So we will take that part because the returning part will take only the constant time. So T of n is equals to T of n minus 1 plus n. Now let's list the equation 1. Now we don't know the value of T of n minus 1. So let's calculate it. T of n minus 1 is equals to T of n minus 2 plus n minus 1. Now I have simply replaced n minus 1 in place of n. So we get T of n minus 2 plus n minus 1. Similarly, we will find the value of T of n minus 2. That will be T of n minus 3 plus n minus 2. So this will be equation 2 and this will be equation 3. Now we will substitute the value of T of n minus 2 in equation 2. So we get T of n minus 1 is equals to, substituting this value in this part, T of n minus 3 plus n minus 2 plus n minus 1. So this is the value of T of n minus 2. Now let's name this equation as 4. Now substituting this T of n minus 1 in Tn. So we get Tn is equals to T of n minus 3 plus n minus 2 plus n minus 1 plus n. So we got this equation. Now we done this for 3 number of times, 1, 2 and 3. Therefore we got T of n minus 3, n minus 2, n minus 1 and n. Similarly, if we do this for k number of time, we'll be getting T n minus k plus n minus k minus 1 plus n minus k minus 2 plus and so on till n minus 1 plus n. So this 2 is nothing but 3 minus 1. Similarly 2 minus 1 will be 1. So therefore k k minus 1, k minus 2 and so on. Now we have to eliminate this function. So let's now see the base condition. When the value of n is less than 1, it will be returning 1. So t of 1 will return 1. Now in place of n, if we put 1, we will get 1. So if we put n1 in n minus k, we will get 1. So n minus k equals to 1. So the value of k will be n minus 1. Now we will substitute this k value in this equation. We get t of 1 because n minus k is 1 plus n minus 1 minus 1 plus n minus 1 minus 2 and so on, plus n minus 1 plus n. Now the value of this is 1, we know that, plus if we solve this, then we will get 2. This n and this n will get cancelled and this will be 2 plus 3 plus 4 and so on till n minus 1 plus n. Now this is nothing but a summation series of first and natural number. So if we solve this series, we get n into n plus 1 by 2. So opening the bracket, we'll get 2 square plus n by 2. Now considering the dominant term, that is n square, so we will have order of n square. So in this way we find the time complexity from the recurrence relation. Now why do we need to calculate in this way? We know how to calculate the time complexity when the code is iterative, but when it comes to recursive code, it is literally impossible to calculate time complexity in that manner. So we use a recurrence relation to solve the time complexity. Now let's solve another question. The question is t of n is equals to 1 if n is equals to 1, or t of n minus 1 plus log n. Otherwise, or we can say if n is greater than 1. So this is the constant part, so we will not consider it. We will take t of n as t of n minus 1 plus log n. Name it as equation 1. So t of n minus 1 will be t of n minus 2 plus log of n minus 1, because we are replacing n by n minus 1. So this will be equation 2. T of n minus 2 will be t of n minus 3 plus log of n minus 2. This will be equation 3. Now substituting the value of t of n minus 2 in t of n minus 1, we get t of n minus 1 is equals to t of n minus 3 plus log of n minus 2 plus log of n minus 1. Similarly, putting t of n minus 1 value in this equation, that is t of n, we get t of n is equals to t of n minus 3 plus log n minus 2 plus log n minus 1 plus log n. Now similarly, if we do this for k number of time, we get t of n minus a plus log of n minus k minus 1 plus log of n minus k minus 2 and so on till log of n minus 1 plus log n. Now we have to eliminate this part. So let's say n minus k equals to 1. Why 1? Because of the base condition. If the value of n is 1, it will return 1. So after this, the value of k will be n minus 1. Now substituting this k value in this equation, we get t of n is equals to t of 1 plus log of n minus 1 minus 1 plus log of n minus 1 minus 2 plus so on till log of n. Now this t of 1 is 1, so if we solve this, we will get 2, this will be 3 and so on. So log of 2 plus log of 3 plus and so on till log of n. Now we will do 1 plus log of 2 into 3 into 4 into and so on till n, because log of a plus log of b is equals to log of a into b. So we get 1 plus log of n factorial. Now what will be the value of log of n factorial? It will be 1 plus n log n. By Stirling approximation. So the value of log of n factorial is nothing but n log n. So you can Google it, what actually Stirling approximation is and how to find the log n factorial value. So it will be order of n log n. So the time complexity of this recurrence relation, or we can say recursive code, is order of n log n. So in this way, we find the time complexity from the recurrence relation that is found out from recursive code. So in the next lecture, I'll show you how to solve the recurrence relation using a recursive tree method. Thank you.